Good day, everyone. Today I'll be discussing process management and operating systems. Process management is one of the core responsibilities of an OS. It ensures that different processes or running programs are executed efficiently without slowing down the system. We will explore that a process is, how the OS manage it, and the key functions involved. Process management overview. In this slide, we see how process management varies depending on the system type. Single tasking system only run one process at a time, so they're simpler. But in multi-programming or multitasking system, multiple processes share the CPU, which requires the OS to schedule and coordinate them efficiently. The OS must also handle resource sharing, memory management, and processing coordination to avoid conflict when processes interact. What is process? A process is essentially a program that is currently being executed. For a process to run, it needs resources such as CPU time, memory, files, and input-output devices. A computer system contains many processes. Some belong to the OS itself, and others belong to users. These processes can run concurrently, meaning they appear to run at the same time. OS responsibilities in process management. The operating system performs several important tasks for process management. It creates and deletes processes. It schedules them to ensure efficient CPU use. It manages communication and synchronization between processes. And it ensures that deadlock situations where process block each other are handled or avoided. Process creation and termination. This slide explains two major events, starting and ending a process. When a process is created, the OS assigns it a process ID and set up a process control block. A process may be terminated by the OS or its parent process. When this happens, the OS frees all resources tied to that process. This slide also highlights CPU scheduling, deadlock handling, inter-process communication, and synchronization, key aspects of multitasking system. Process management task. Process management is central in system that supports multitasking. The slide shows a process includes more than just the program's code. It also includes the program counter, CPU registers, the process stack for temporary data, a data section for global variables, and a heap for dynamically allocated memory. All these components help the OS track of the process execution. Process concept. These slides outline the different elements that make up a process. It emphasizes that a process is not just code. It is the combination of memory, data, and execution state that makes it runnable by the OS. Process state. This slide shows the 5 common states of a process. New, the process is being created. Running, the CPU is currently executing the instruction. Waiting, the process is paused, waiting for an event like input-output completion. Ready, the process is prepared for run. No, to run, but is waiting for CPU time. Terminated, the process has been complete. Process control block. The process control block is like the identity card of a process. It stores all important information the OS needs, such as the process ID, the current state of the process, CPU registers and the program counter, memory management detail, accounting information like CPU usage, input-output device allocation. Without the PCB, the OS wouldn't be able to pause and resume process properly. Process control block. The process control block is like the identity card of a process. It stores all important information the OS needs, such as the process ID, the current state of the process, CPU registers and the program counter, memory management detail, accounting informations like CPU usage, input-output device allocation. Without the PCB, the OS wouldn't be able to pause and resume process properly. Process control block. The process control block is like the identity card of a process. It stores all important information the OS needs, such as the process ID, the current state of the process, CPU registers and the program counter, memory management detail, accounting informations like CPU usage, input-output device allocation. Without the PCB, the OS wouldn't be able to pause and resume process properly. Process control block.